Hello everyone, welcome to the concept of double integration. In this video, we will be specifically looking into how to change the order of integration. Now the question is, what is the order of integration? Order of integration means if first integral is with respect to x and second is with respect to y, then we are saying x is the first variable of integration and y is the second variable of integration. So that is called order of integration. So this integral we have to solve with respect to x, and then its solution becomes the integrand for next integral, which is with respect to y. Now change the order of integration means if given order is x and then y, we have to change it first y and then x. Now through example we will be looking into. In this example, function is not specifically given, it's a general function given as a notation, and dx dy. So we will not decide the order of integration from how this dx and dy is written, whether it is dx dy or dy dx, doesn't matter. We'll be observing the limits. Now these limits, these first integral limits, are the functions of y. 0 is the constant and upper limit is root of a square minus y square. So this is a function of y, and that's why this is x limit. So this is x is equal to 0 and x is equal to root of a square minus y square. So first variable of integration is x, and then of course second variable of integration is y. So these four limits are nothing but the four curves we get. So x is equal to 0 is the first curve, a straight line, y-axis itself. Then x is equal to root of a square minus y square. After squaring, we get x square plus y square is equal to a square, a circle. Then outer integral limits, y equals to minus a and y equals to a, gives you to another straight line. So if we draw them, we get this shaded region. Why this shaded region is the given region of integration? Why not full circle? Because you see x is equal to 0. So given strip is the black strip, given region. If we consider this black strip, this strip is satisfying the limits where x is varying from 0, it means y-axis. That strip is starting from y-axis till that strip is ending on the outer boundary of the circle where x is root of a square minus y square. It's a circle. And then y varies from minus a to plus a, means here y is equal to a and here y equals to minus a. So with this only shaded region is satisfying the given limits. That's why. Now they have given the horizontal strip. Now we will be considering vertical strip. If vertical strip, that red color strip, if we consider, that strip is starting from circle ending on circle. So we have to convert this circle equation into y equals to form. So circle equation is x square plus y square is equal to a square. So y square would be a square minus x square, and that's why y is plus or minus root of a square minus x square. Since we are in fourth quadrant, y is negative, that's why y varies from here, that is negative root of a square minus x square, to that strip is ending on in first quadrant where y is positive, that's why plus root of a square minus x square. So circle is same, but the values of y are negative and positive respectively. Once the strip limits are done, we are considering full region for the x, and since it's a region, it starts from one point to another point. So leftmost point of x is nothing but y-axis itself, where x is always 0 throughout the y-axis, and see that entire region is ending on this point where value of x is a. It's a radius of circle. That's why these are the constant limits for x. We always put strip limits for the inner integral, which is for y now, and constant limits for outside the integral, which is for x now. So this is what the order of integration changed. So I repeat, order of integration means if first variable of integration is x and then y, we have to make it y and then x, and vice versa for x and y. Let's have a look on one more example of similar type. We have changed the order of integration. Again here function is not given. Some notation for the function is given. Therefore observe the limits now. Again these integral limits are in terms of y. A minus root of a square minus y square, a plus root of a square minus y square. So these are the limits of x. So where x is varying, it means first variable of integration is x and then y. So this is the order of integration. These are the limits of y. Now we have to make y first and then x. So to make y first, we have to consider vertical strip because vertically y varies. Now given strip is horizontal. Now these four limits are nothing but the four curves as already we have discussed. So lower limit of x is a minus root a square minus y square. If we shift a on this side, it becomes x minus a is equals to minus root of a square minus y square. Squaring and adjusting the constant, we get x minus a square plus y square is equal to a square, a perfect equation of circle with center a comma 0 and radius a. On the same line, x is equal to a plus root a square minus y square gives you same circle with center a comma 0 and radius a. Whereas y limits are given as y equals to 0, a straight line, rather x-axis, and y equals to a, another straight line. So these four curves, one circle and two straight lines can be drawn this way. So if we draw, area of integration is the shaded region. Why only upper half? Because y is varying from 0 to a. So here is the y limit, 0 to a. Here we have minus a. The value of y is minus a. And first variable of integration is x. So that black strip gives us the given limit. So on this strip, limits are satisfied. It is starting from circle, ending on circle. So circle equation a minus and a plus. Now we have to change the order of integration, means we have to consider vertical strip. Now in vertical strip, y varies always. So that strip is starting from y axis where y is 0. So lower limit of y is 0. That strip is ending on the circle boundary. So let's convert circle equation into y equals to form. Currently it is y square plus x minus a whole square is equal to a square. So y square will be a square minus x minus a whole square. And then y is plus or minus root of a square minus x minus a whole square. Since we are in first quadrant, y will be positive. That's why positive root. It's the upper limit of y. Now in region, full shaded region gives you x limits, leftmost point to rightmost point. Leftmost point of x is 0, 0 and rightmost point is x is equal to a line, that is a, 0. And that's why limits of x is 0 to a. And if you put this limit 0 to a outside and this integral, here we have 0 to root of a square minus x minus a whole square, some function dy dx. So you can see now this is for y and this is for x. So given order was first x and then y. Now it is first y and then x. That is what we have changed the order of integration. Now if function is well defined here, we can integrate, rather we can evaluate this integral. One more example of this kind. Change the order of integration and evaluate. Again we cannot evaluate because function is just given as a symbol f of x comma y. So let's concentrate on the limit. As usual, four limits are nothing but the four curves. So first integral limits are in terms of y. That's why they are the limits of x. So this is x is equal to y minus 8 by 4 and x is equal to y by 4. So x is equal to y minus 8 by 4 gives you the straight line equation y minus 4x is equal to 8. Then upper limit of x is y by 4. So it is nothing but y equals to 4x, again a straight line. And outer integral limits are for y. That's why y equals to 0 and y equals to 8, another two straight lines. So all curves are nothing but the straight lines. Now to draw straight lines, we need at least 2 points. So if you put x is equal to 0, we get y as 8. So this is the 0, 8, one of the point on that line. And if you put y as 0, we get x as minus 2. So we get another point minus 2, 0. This way we can find out 2 points lying on that line. Similarly, if x is 0, y 0, it is passing through origin. And if x is 1, you can put any value. So if x is 1, y is 4, so we get another point. So if we join all these points, we get this kind of diagram. Here is the origin. This is x-axis, this is y-axis, and we have 1, 4 and 0, 0 line joining this, which is y equals to 4x, and 0, 8 is somewhere here, and minus 2, 0 is somewhere point A if we join them. So you can see this point, this line AB and line OC are like this only. They are not parallel because this distance is 1 and this distance is minus 2, means 2. That's why they are not parallel. They will intersect somewhere. But for us, this is the shaded region, required region of integration. Why the shaded region? You can see the limits. If we now first integral limits are of x, that's why they have given the horizontal strip. So this black strip satisfies the limits of integral. So on this strip, x is varying from this straight line where that straight line is y minus 4x is equal to 8, which is nothing but x is equal to y minus 8 by 4. And that strip is ending on y equals to 4x line, which is the second limit. And the region satisfying y limits also, y varies from 0 to 8. So this entire region is satisfying. But the thing is, this was horizontal line. That's why if we move this strip throughout the region, we get uniform limits. That is, that strip is starting from same curve and ending on same curve. But now to change the order of integration, we have to put a vertical strip. But if you see, vertical strip, if you draw it here, it starts with line AO or x-axis, and if you draw it here, it will start from y is equal to 4x and ending on another line. That's why it is not giving us uniform limits. That's why the partition is required. So y-axis itself a partition, so that you can say AOB. In this triangle AOB, if you move this strip anywhere, it is not changing value. It is starting from AO line and it is ending on y minus 4x is equal to 8. On the same line, we have region BCO, where if you put a strip, it will start from y is equal to 4x and ending on y is equal to 8. So we have two regions. That's why two strips are required with the partition OB. Now we'll go region wise. In region AOB, consider the vertical strip, of course, the red strip you can see. Now this strip is starting from line AO where y is 0. That's why y equals to 0. Remember that vertical strip reflects the limits of y, horizontal for x. So vertically y varies. So y is varying from 0 to. That strip is ending on this straight line. This straight line equation is y minus 4x is equal to 8. So y is 4x plus 8. So these are the limits for y. And in that triangular region AOB, leftmost point of x is point A, where value of x is minus 2, and rightmost point is nothing but the y-axis itself. That's why x is equal to 0. These are the limits for region AOB. Now in region OBC, we can see that strip is starting from this straight line where y is equal to 4x is the lower limit of y, and strip is ending on a line y equals to 8 is the upper limit of y. In that triangle, we have x limits leftmost point to rightmost point. Leftmost point is nothing but the y-axis where x is 0, and that triangle is ending on point C. That's why at C, value of x is 1 is the upper limit of x. If you put all this together, we write in given integral as addition of two integrals. First region is AOB where x is minus 2 to 0 and y is 0 to 4x plus 8. Now you can see given order was first x and then y. Now we have first y and then x for both of them. This is x limit, this is y limit. Now we'll consider one more example which is of evaluation type after changing the order of integration. These limits are the functions of x. That's why these are the limits of y and these are the limits of x. It means first y and then x. This is the order of integration. What we have to do? Now first x and then y. To do that, we must have region of integration. For that, we must have all the curves. So we have lower limit of y, that is 3 minus x, which gives you a straight line equation x plus y is equal to 3. Upper limit of y is 3 plus x, that's why y minus x is equal to 3, another straight line. And then outer limits, x is equal to 0, x is equal to 5. All are straight lines. To draw these straight lines, we have 2 points on the line. That's why if you put x as 0, we get y as 3, and if you put y as 0, we get x as 3. So these are the 2 points sufficient to draw a straight line. Similarly, if you put x as 0 and then y as 0, we get these 2 points. If we join them, we get this area of integration. Now question is, why only the shaded region is the area of integration? Why not this? Of course, we have to go back to the limits given. Now first variable is y. It means their strip is vertical. So if we put vertical strip in the region like black strip you can see here, only that strip is satisfying the given condition. See, that strip should start from y equals to 3 minus x. So y equals to 3 minus x means x plus y is equal to 3 lines. So yes, see, y equals to 3 minus x is the line AB. From that, strip is starting. Strip is ending on y equals to 3 plus x. Yes, strip is ending on y equals to 3 plus x. Also, we have to check for x limits. X is varying from 0 to 5. Yes, at point A, x is 0. At point or on line DB, we have x 5. So only this region is satisfying the given limits of integration. Okay. Now they have given y first. It means they have considered vertical strip. Now we have to consider horizontal strip. But if we consider horizontal strip, we require a partition. How? See. In this region, if we draw a strip, it is starting from y equals to 3 plus x line. But if you draw it here, it is starting from y equals to 3 minus x. Where it is changing from? From the point A. So we put partition in AC. Horizontal partition for horizontal strip. Okay. Now in region ADC, we have strip uniformly moving in the region, which gives us uniform limits. Whereas in region ABC, you can see there is no change in the limits if we move the strips in between. So let's go region wise. In ABC, that is the lower triangle, horizontal strip gives you x limits first. So that strip is starting from line AB, where value of x is 3 minus y. We have to rearrange this equation. So x is equal to 3 minus y, and strip is ending on the line DD, where x is 5. Now in that region, y varies from bottommost point to topmost point. So bottommost point of this area is point B. That's why at B, y is minus 2, and at it is topmost point is line AC, where y is 3. So these are the limits for first integral. Now in another triangle ADC, on this strip starts from line AD, which is y equals to 3 plus x. So x will be y minus 3, and it is ending on x is equal to 5. Similarly, in that triangle, y starts from line AC, where y is 3, and it ends on y equals to 8. These are the limits of y. If you put all this together, we get this integral. Now we can evaluate this because function is well defined. It is a constant function 1. So we can integrate this. Now integrand is 1. That's why, and first variable of integration is x. So its integral will be x in both upper limit minus lower limit. You can see like this: 5 and 3 minus y, 5 and y minus 3. So x gives you 5 minus lower limit. So because of minus sign in lower limit, 3 minus y becomes minus 3 plus y. On the same line, x with upper limit 5 minus x with lower limit y minus 3, because of minus sign, minus y plus 3 we get. If we simplify, we get 2 plus y and 8 minus y. Now integration with respect to x is over. Now left is with respect to y. If we integrate, 2 becomes 2y, y becomes y square by 2, 8 becomes 8y, and y becomes y square by 2. If you put upper limit minus lower limit, this is upper limit minus lower limit, upper limit minus lower limit. If you simplify, you get the answer of integral value as 25. With this example, hope your concept of changing the order of integration and evaluate if function is given is clear. Thank you.